The nerve impulse is an electrical signal that conveys information along a neuron. The series of events that causes the electrical charge inside a nerve cell to convey information and go from a resting state to a depolarized state and back to a resting state is known as the action potential or nerve impulse. We begin with the resting or polarization phase. In this state, the chief intracellular ions include the positively charged potassium ions, K+, and several negatively charged ions or anions. During the resting state, the potassium ions tend to leak out of the cell. When they do, they take the positive charge with them, resulting in a negative environment within the cell. When the neuron is stimulated, the membrane becomes permeable to sodium and allows sodium ions, Na+, to cross over the membrane into the cell. This increase in sodium with the diffusion of positive charges changes the inside of the cell, making it now a positive environment. This is depolarization. After the impulse has passed through, the cell membrane again changes. It no longer allows the diffusion of sodium into the cell. In fact, the sodium begins to be removed by pumps located within the membrane of the neuron. It also allows potassium to once again diffuse out of the cell. This outward movement of the positively charged potassium ions removes the positive charge from the inside of the cell and leaves behind the negatively charged ions, which causes repolarization. If the traveling impulse encounters a section of membrane covered with myelin, it jumps around the myelin. This type of impulse travel is much faster than is possible in non-myelinated sections and is known as saltatory conduction.